Hello and welcome to a new episode of Shortcut, the podcast that takes you on a shortcut to developer experience, developer productivity, and product engineering. I'm Morten.
And I'm Marilag, and you are watching the second part of the episode with Thomas Jespersen. And in the previous episode, we talked about his story, working as a CTO for several successful startup companies that have scaled up, and how he's helping different companies and building very, very good engineering practices to advocate empowering engineers. And we talk about how to remove silos inside the organization. We also talked about in the previous episode what is the best engineering flow for the success of the product. And I encourage our audience, our listeners, to check back episode number 4 of Shortcut.
Yeah, and in the last episode, I was just about to ask a question around developer experience, because when we talk about developer experience or hear about developer experience, it's almost always in the context of fairly big companies. Like we talk with Lego and Maersk, and in the context of Novo Nordisk, and for Danish companies, it's always fairly big companies. So since you're working with smaller companies now, and you've been in a startup that's been a scale up and grown and acquired other companies, what's your take on developer experience from the perspective of a smaller company, a smaller engineering team?
Mm-hmm. So, as you said, in big companies, we typically talk about developer platforms, these big places where you can go and find out what are the different systems and so on, and things like that. Maybe you don't need that in a small startup. So for me, it's more about, getting a good, as what it says, developer experience. And what does that mean? I think one of the things we had in Templafy was that we had this idea, this concept that when someone new joined the company, they should be handed out a laptop in the morning with nothing installed, Windows or Mac, and then within 3 hours, they should be able to get up and running, and ideally do a deployment to production the first day. We talked about why it's important to do a lot of daily deployments. So for me, again, getting to this point where, setting up a new developer environment from scratch should be so easy and simple that, it's joy. And again, it comes back to how do you do that? And we had, a big platform, and now I'm talking about Templafy again, and we had several systems, and where should you start and how should you do? And we did have not a developer platform, but as I mentioned last time, we used as a DevOps, and now it's just an example to say how it could look like. But we had a wiki page, and that wiki page says, new engineer, and at the bottom it says welcome, and say, follow this guide to get up and running. And by the way, make sure that if you find anything that does not fit, maybe you have to install a version of something and it fails because it's a new version or whatever, update the thing and hand it over to the next person. And this is something very small that I think everyone can do. Now it gets to, for me, the developer experience is very much about a smooth flow. I think we are going to talk a lot about team topologies maybe in this episode, and there's this thing about cognitive load where if you have to do a release or you have to do anything, you have to know, okay, I have to go there, and then I have to right click there, I have to send a mail, and whatever it is, those kind of that knowledge, it's not very valuable, because it takes up the amount of knowledge that you can have, and it means that you can only focus on a very narrow thing. And I want to focus on getting out all that repetitive work, all that bureaucracy out of the way. So developer experience in a scale up or in a startup is very much about a smooth process. And we could also talk about, we talked about a lot about releases last time, your build pipeline should be fast, not the hours, and it should be easy to get a local certificate up and running if that's required by you, and get test data so you can, all those things, eliminate all these manual step and try to automate it. That's, one thing about developer experience. If I can add another thing that we had in Templafy, which I also adopted on platform, is we created a developer CLI. It's actually our good friend Morten Rasmus Krohmann, who was my principal engineer and later also CTO after me in Templafy, who said, we need this tool that people can hack so they can, start automating things. And since we work in C#, we create this C# project, and you can just make a new file with a command. Last episode, I talked about something where we could automate translation back and forth. And it's just one file, and it's part of your source code, so you check it out. And as soon as anyone gets it down, it recompiles. It detects automatically that something is, has changed. So that means that everyone in the entire engineering organization have the latest version of the developer CLI. And it's not pushed by, we are NuGet or anything else or the network drive. You literally just check out the code. You can even go to a different branch, and then the developer CLI will match what you have there. And as I said, it's part of platform, and you can take that single thing in yourself. But it was such a great way to start automating things. And I think now I might put out a number that's completely wrong, but there were several hundreds commands that the different teams in Templafy made to optimize whatever they worked on. At least it was very easy to do that. And for me, in startup, that's a great way to start about developer experience. Then you can go to Backstage and all the other kind of tools when you grow bigger.
Like you start exposing this, but you start with having a way to automate the most common tasks. But that's also talking about developer velocity, which is certainly very good for experience. We all would love to do our tasks much quicker. But then there's also another side of developer experience wherein, your creative side as an engineer. We're all in the business of building something and something new. And, we like to pick our tools, the right tools, just like painters like to pick their own colors and brushes. And that's also part of the experience. So, in your teams, how do you balance that, giving that flexibility for developers with their creativity to pick the right tools, but then also maybe that will slow them down because they're starting from scratch all the time or doing the latest and greatest? Yeah, what's your take on that?
Yeah, so you're picking on something that's, really hard, and it took me quite a long time to get to a point where I felt that, we nailed it. Because, okay, developers should pick the right tool. But now I'll take my CTO hat on, and I had 80 engineers when we were at the most. And someone would use that tool or maybe that programming language or that programming paradigm, and that might be good for that person, for that team. Then they could, okay, we'll take Vue.js because we are extremely good, and the other teams will go with React, or some will use TypeScript, some will not. And the challenge is that might optimize the team and the way they work. But as a CTO, it was not really, perfect, because I wanted to optimize the entire engineering organization and the collaboration between the teams, but not even that. I mentioned in the previous episode, we did 3 acquisitions. We had to onboard other companies, and we had to change the team structure. When you grow from, one team to 2 teams, you have always to split the teams and mix. And if everyone is, if I hire a Ruby developer, and then I hire a Java developer, and then a .NET developer, and then you say, now you go, not everyone is, like to go back and forth. And then there comes all this debate. So that was a huge, thing we talked about. And I have a gut feeling, because I'm a bit on the spectrum. So and everyone from Templafy knows, I wanted what we said, operational consistency. So I also talked about these 30 deployments we do per day. And if every team has to, build their own pipeline and figure out how to do automatic translation or whatever it is, it's just a lot of things where you do the same thing over and over again. So 2 things. In the early days, halfway in, we went from a monolith to we called them self-contained system or big microservices. We can talk about that. But at that point, I needed to figure out that I need to step back as a CTO, and I couldn't dictate what everyone was doing. But we we used the Spotify model, and I do a quotation mark because not even Spotify is doing the Spotify model. We were inspired by Spotify, and we had 8 squads. That's last episode we talked about empowered teams. We went back to teams later, but how do you get 8 teams to work in a consistent way? And one of the great tools that I really can encourage people to look upon, no matter where you are, is we created guilds. And guilds is this concept that Spotify introduced where people get together across different teams. And we had 7 guilds. We had a front-end guild, a back-end guild, a DevOps guild, a cloud guild, a QA guild, a security guild, and I can't remember the last one. But every week, people from different teams joined different guilds. And Wednesday morning from 9 to 12, all the guild meetings was, and people was just jumping around and going into the different guilds. And in the .NET guilds, they discussed what testing framework should we use. And in the front-end guild, they said, should we use Redux or React or what? And then instead of having each team decide on their own, they discussed it in the teams. At some point, they started voting on it, and that didn't went so well. So I said, if you vote, just ask me, I'll pick. Because so they had to, get to consensus, and that slowed down a lot of the decision making. But it ended up making sure that all teams were operating with the same technology stack in the same way, and not even that, because then the guild said, we should use Cypress for testing, and we should do data annotation on our HTML attribute this way or whatever. And then they put that back on the teams, or the squads. And the product, that was before product managers, we had product owners back then, they said, but we don't have time for that. So we figured out that it was too easy for these guilds to just decide we should do all these cool things. So what we ended up doing was saying, okay, when you decide something, you also have to figure out who's doing it. And then they picked 1 or 2 members of the teams who say, if we are going to introduce Cypress and data annotation in this specific way, you go into all the different systems and do that. And then those 2 people, for instance, went out at one point and made, in that place, I think we had 12 of these self-contained systems. They made 12 pull requests. But now all of them were exactly the same. And the teams didn't have to do it. And it was at that point of time, it was just great, because we were changing everything to .NET Core and Docker and Kubernetes and new CI/CD pipeline, and people learned a ton. And this discussion in the guild, it was just amazing, And I got operational consistency. Everyone worked the same way. And so the problem, whenever I tell this, is we can't do that, because I could do that because we started on early on. Most companies can't do what I just said here. But it worked for us, and it was really good.
Yeah, I think we also talked a little bit about that in our previous episode about building engineering communities, or a strong engineering community. And I like your take on it that, okay, they're happy with their deals in their community, but for you as a CTO, you get operational consistency.
Yeah. And it was also a way for me to kind of step back and if I had 5-10 people talking about how we should do our distributed message architecture, then there was so many people discussing it, and they came up with quite sensible, choices. And there was always someone who said, no, I work with that. There was always an experienced person on all the engineers that could, make sure that everyone took a right decision. There's not do a bad decision. Instead of this thing where you go into a team, and then there was this engineer that we hired 3 years ago, and he decided that we should do it this way, and now this is how it works. So there's very few bad decisions. And plug again, I'm working on this platform where I'm trying to codify. This is the open source system I'm working on, where I'm trying to codify a lot of these engineering practices. And I obviously didn't copy any code, but there's a lot of these things, how you do this thing or that thing that, I'm trying to, just open source and show how to be done.
And I think this applies well with a bit larger team, But how about if you're just a startup with 5 engineers and you want to pick the tools? Do you have any guiding principles? Just pick whatever.
No, I mean, okay. So again, now with platform is it's a full platform with all these things. It's not completely, it's not version 1. I call it alpha or beta, but there's a lot of things. So you can start with that and reach out. I would be happy to help you get started. But that's not your question. I think the important part is that you make sane choices. And I think if you're a small startup, you should pick the tools that you know and are comfortable with, whether that is a Ruby or TypeScript or Node or Next or whatever. But also, I would say, try to pick something that is not just a new hype. I mean, try to pick something where you can hire people, you can grow your business. Don't take the latest and greatest tool that you just read about because you think because I've seen it so many times through my career. I come out to someone and say, someone picked this tool, the person is not here, and but we're stuck with it and we don't know how to get rid of it. So do sane choices. And then lean upon, someone. And I think if you're in the Node.js, that's the Vercel setup where you just get, a good starting point. In other languages, you have to figure out what is the good starting point.
Yeah, and so I think one thing that's interesting, like maybe following from that, is talking, maybe diving a little bit more deeper into architecture, because some of the hype is, or have always, for a long time been around microservices, and I can see a lot of developers jumps on that, right? And I think from a startup perspective, maybe that can be a little bit dangerous to jump on that.
Oh, yes.
And there are lots of talks around how you go from a monolith to microservices, and maybe even going back to the modular monolith. So from your perspective, where should you start?
Yeah. So definitely as a startup, no matter what, start with a monolith. Even if you eventually have to go to microservices, start with a monolith, because it will speed up things. The whole thing we talked about last episode with the continuous deployment, and it's just really hard to have any kind of distribution where you have to have system in sync and they scale up and scale. And the first thing is microservices are not invented to scale systems. If you have a monolith, you probably don't have scaling problems. Just buy bigger hardware in the cloud. You can buy bigger virtual machines. You can buy bigger databases. It's very rare that you can't do that. Actually I haven't, but I've heard about someone who claims it won't work for us. So let me just be crystal clear. Microservices has nothing to do with scaling architecture. The problem microservices are solving is scaling teams. And we talked about, I said, that we went from a monolith to what I call self-contained system, or I'm not sure if this is the same with the model, with distributed monolith or
modular monolith.
No, but I think, okay, okay. Self-contained systems that I am advocating is that one team gets one system. And one of the things what I did in Templafy, why we created these 8 squads, was I had 8 systems. One system per team. And my job back then was, because there's this thing called Conway's Law, and it goes back to the SysDevs. I actually don't know what he was, but he coined this phrase that if your software architecture is a mirror of your organization architecture. So I created 8 teams, and they would always optimize for their own flow and try to avoid dependencies on other teams. Back then, he said, if you make a free teams, you get a free step. If you build a compiler and make free teams, you get a free step compilers. I don't even know what that means today. But I had these 8 teams, and I needed to make sure that these teams could work independently. And please, by God, do not create a front-end team, a back-end team, a QA team, and a development team. That's not what we are talking about. You need to do these vertical slices where each team can work independently and do, again, these multiple deployments per day. And your goal is to build an architecture where you minimize the dependencies between the different teams or the different systems. And no way should there be that you need to deploy yours before I can deploy mine.
Yeah.
I mean, each team should go as fast as they can and be able to work in isolation. Last episode, we talked about empowered teams, and they should have objectives so they understand what customer pains they have. So you should also structure your teams around business outcome. That's very, very hard. And again, we're sitting with teams.
I was about to say, it sounds like streamlined teams.
It's exactly the same. And I actually happened to have a whole dinner with Matthew Skeleton a month ago where, I think it's a shame that they picked the name Streamlined Teams, because it's, if I talk to anyone, nobody knows what it is. So even though that we adopted team topologies later on when we grew from these 8 teams, at some point we changed it to teams and not squads, and we introduced platform teams as the book describes. But so that's in the book. There's the platform teams, and there's also enabling teams and specialized teams, which we did not have. But we didn't call it streamlined teams. We called them empowered product teams, and that's more to the Marty Kagan way of thinking, and also because we had these product trios that was doing the discovery we talked about. So, but the point was that every single team, at least we tried to have a business goal. But disclaimer here, I got a lot of I wouldn't say resistant, but I talked about silos last time, and I was not 100% aligned with the rest of our business, and they didn't see the product and the things we were building in the same slices. That I really did my best, and I talked to the customer. But at some point, we figured out in Templafy that we want to work in a different way. And that was really hard to that didn't fit Conway's law.
Yeah.
And it's one of the reasons I'm not with Templafy anymore, because I didn't really succeed with that way of working, even though I'm advocating. I feel it so strongly that the teams need to be able to see the business outcome and work autonomously.
But I think that's probably one of the hardest thing in this paradigm, right? What is a system? How big is that? How big is that team working for that system? How do you quantify what you would consider a system?
So again, you asked 2 questions here: quantify the system, and then how big is the team? And there's this, I think Amazon became very famous for the 2-pizza team. And we're living in Denmark, and that's a 2-person team, yes. Because but I think if you look it up, it's like 5 to 9 people. Less than 10. That's a small team. And again, that's also what's advocated in team topologies. But I am actually personally, I think we are in an age of AI where you can get a lot of power. So I'm advocating even smaller teams nowadays. But that's a different discussion that maybe we should. But coming back to your question, I think ideally a team should have one system. But you can do that as we did when we split the teams in Templafy. But at some point things happen. A system is no longer that important anymore. You have to maybe authentication was a good example, and user management was okay. It's kind of done now. But in Templafy it was huge because we had these huge enterprises. So that was actually 2 teams, and we collapsed them. There was also something account management. So now we collapsed 2 teams, and they had true system, and maybe there was some other things, and suddenly your architecture does not fit the team structure, and there's no magic trick here except for be conscious about it, and even try. You said going back. I mean, I know I didn't do, but I know a lot of people in Templafy said we should collapse those 2 systems because it's just one, and by all means do it. And as you said, Morten, there's a trend in the industry where people go to microservices. And when we talk microservices, we talk 100, 1,000. I've seen companies of Templafy's size have several thousand microservices, small things, doing things, and it's just like it's so hard because now your dependencies and the architecture it's slow to work that way. So I advocate this thing called self-contained system where they're much bigger. It's a team of 5-10 people, working on it for several years, and they keep working on it. So that's why I call them small monoliths, because they go, and it's all the way from the front end to the back end to the database. The biggest problem is we were building one product, and how is the front end? You have these things, and how does it feel like one front end? And what we did was we created micro front ends. So now it becomes technical, but so I'll try to keep it short. But literally, you could load a single page app that could dynamically load parts of the module from other systems in a way where you could release them. And by the way, plug again, I have this in platform using something called Module Federation, which if you go into the Azure portal or somewhere, you can navigate around forever, and it feels like it's just one app, but it's not.
Yeah.
I haven't actually seen anyone doing that except the very, very big companies. But that's what enables, these streamlined teams or the empowered teams to work in isolation without coordinating.
Yeah.
And I think these concepts that you have mentioned, most engineers are aware of the fundamental principles, but the application, that's where we're lacking, right? Like, how do we really do correct micro front end or correct monolith, or because it can also go wrong, or correct way of doing this, what do you call that? The self-contained systems, right? So do you have any advice where to get started and how to do this right?
It's hard, because as we talked about last time, it's not about only the architecture. It's also about all these things that every system needs to have with localization and tracking, monitoring, and it's not easy, and it requires a lot of technical excellency and engineers that know how to build it. And to be honest, very few are capable of doing it, and even if they are typically working in a place where they are not allowed to do those kind of things. And I talked about how the guilds work in Templafy. That was one way to kind of like work that. Later, by the way, the guilds is still kind of existed, but we created these platform teams. So I created 4 smaller platform teams, one for the front and back end, and for the DevOps and the data team, that could kind of like do these things and ensure that we had the operational consistency, because there was so much work in the guilds. And that that's a place. So you find some people who are capable of doing these kind of things, but as soon as you get to multiple system and at scale, it's just you have to have a lot of expertise to get these things up and running. And we talked about developer experience in the beginning, still needs to be smooth and so on. And it's hard.
And I think in wrapping up for today's episode and for this 2-part series, we usually ask our guests to provide a shortcut to our listeners. So given your experience, can you provide our listeners with a shortcut to achieving these good engineering practices that we've talked about?
A shortcut, seems like that's a way to cheat our way to it. So in that regard, it's not a shortcut because it's hard. And I think it's coming back to what we talked about last episode, and I mentioned it so many times. But the deployment frequency, being able to deploy whatever product you're working on daily, is so important. And twice a week is not good enough, because as soon as you go to twice a week, you have to figure out how do you make a hot fix to something. Now you have to have branching strategies and so on. So we call it trunk-based development. So that means every time you make a new thing, you make a branch, you make the thing and make a pull request and merge it out. That's, trunk-based development is little commit to trunk and deploy to production. Yeah. But if you have some kind of compliance where we had to, we had to ensure our customers that there was at least 2 people, working on it. And I have another shortcut, and that's maybe even more controversial, if you have time.
Yeah.
We all hear that you should not disturb an engineer who's in the zone. And if you, as us, did 30 production deployments per day, that means 30 pull requests per day. Now I'm creating a branch. I work and I make a pull request. Now, how long time does it take to merge a pull request? An hour, a day, a week? I asked my engineering teams at some point to say, okay, when you have a pull request, you go in a Zoom call and you wait to get a review. So you get a review in seconds or minutes. And that means you have to drag someone out of the zone to get a review. But you get to stay in the zone. Whoever is doing it, and you can get the review, you can merge it down, and you can deploy right after. So that might be the shortcut. And that's actually doable. Whenever you have, if you're using pull request, make sure you get a peer review, not writing. Get into a Zoom call where you can give feedback within minutes, seconds. And that will speed up flow automatically. So that's probably that is a shortcut, and it worked.
Yeah, so maybe for the other shortcut, that's more about a shortcut to being a more product-led organization, where you actually have those practices in play. So in order to excel in product engineering, you have to have these practices in place. And then the shortcut for flow or for fast flow, getting these things, getting these pull requests into production, is rapid review on all requests.
And the thing about this, the rapid review of pull requests, it also means that you can minimize work in progress, because I have whatever tool you're using, a ticket card or work item, you move it into progress, you get a review, you get it done, and then you can start the new one. You never, as an engineer, have multiple things in progress, which I guess most do. But if you follow this shortcut, theoretically you won't. You'll never be working on two things at the same time.
That is interesting, because I was actually just hearing a podcast yesterday where one of the researchers from the DORA report were talking about a metric around pull requests that was a somewhat controversial metric to add, because often it refers back to an individual developer or something like you could easily end up reviewing the developers on why does it take so long to get these pull requests reviewed. But it's actually something you can look at and see, do we do well in this area? Then you're also maybe likely to be better at doing continuous integration and delivery.
You're completely right. And we talked about the DORA metrics, where they lead teams. They have a lead time to production less than an hour. And if the build pipeline takes 15 minutes, half an hour, and from you committing your code to running on production in less, you need that. You can't sit and wait and have a one-day review. You need it literally right away, in person. Because the other thing, when it's in person, if people have a comment and say, I don't like your code, or this is wrong or whatever, it's so much easier. So, it's a small thing, but we typically do this or that. Could we make this? It adds much better flow in the engineering organization when you do peer review. If you do pair programming, on the other hand, the pair can just
completely,
the program merge it together.
Yeah. And I'm going to do a small plugging, because one of my great friends, Adrienne Tucker, is an engineer. She's also just reading a book called Looks Good to Me, and it's all about humane code reviews. So maybe that's also helpful. But thank you so much, Thomas. And I think our listeners have learned a lot on how to empower engineers.
Pleasure being here.
Thank you.
And thanks for listening.
That's a wrap for today's episode of Shortcut. If you enjoyed our discussion, please subscribe, rate, and leave a review on your favorite platform. Sign up for our Shortcut newsletter at our website, Shortcu.tt, and receive our latest podcast straight to your inbox.